Today let's begin section 7.2, Dividing Monomials. We will start by learning several properties just as we did with the multiplying monomials in the last section. The first property is the quotient of powers property. To divide two powers with the same base, subtract the exponents. So for example, c to the 11th power divided by c to the 8th power equals c to the 11 minus 8th power equals c to the 3rd. In example 1, we'll simplify the expression. And also you need to assume that no denominator equals 0, because you need to recall that anytime there's a 0 denominator, it's an undefined fraction, and we cannot have an undefined fraction. So we have x to the 3rd times y to the 4th divided by x to the 2nd times y. This is going to equal x to the 3 minus 2 times y to the 4 minus 1, or x times y to the 3rd power. Let's try one together. In guided practice 1, we have k to the 7th power times m to the 10th power times p divided by k to the 5th power times m to the 3rd power times p. This will equal k to the 7 minus 5 power times m to the 10 minus 3 power times p to the 1 minus 1 power, which leaves us with k to the 2nd times m to the 7th times p to the 0. Now, we haven't talked about the 0 power yet, except that you did discuss this back in pre-algebra last year, but we will be discussing the 0 power soon. And the 0 power, anything raised to the 0 power other than 0 itself, equals 1. So if p to the 0 power equals 1, then we're left with k to the 2nd, m to the 7th. Now you try it. In self-check 1, m to the 4th times p to the 2nd divided by m to the 2nd times p. Let's look at our next property, the power of a quotient property. To find the power of a quotient, find the power of the numerator and the power of the denominator. So for example, we have 3/5 raised to the 4th power. That means we're going to raise 3 to the 4th power and 5 to the 4th power. You could also go ahead and use a calculator and figure out what 3 to the 4th power over 5 to the 4th power is, but we can go ahead and just leave it like this for now. In example 2, we have the power of a quotient. 3x to the 4th divided by 4, all raised to the 3rd power. So notice the parentheses is around the whole expression, so we raise everything to the 3rd power. So 3 to the 3rd power times x to the 4 times 3 power, because x was already raised to the 4th power, divided by 4 to the 3rd power. 3 to the 3rd power is 27, x to the 4 times 3 is x to the 12th, and we're going to divide that by 4 to the 3rd, which is 64. So the answer is 27 x to the 12th over 64. Now let's try one together. In guided practice 2, we have 5 times x to the 5th times y divided by 6, all raised to the 2nd power. So we'll take 5 and we'll raise it to the 2nd power times x to the 5 times 2, because we're raising the x to the 5th to the 2nd power, times y raised to the 2nd power. And we'll divide that by 6 raised to the 2nd power. So when we work this out, we get 25, 5 squared is 25, x to the 10th, y to the 2nd, over 36. 25, x to the 10th, y to the 2nd, over 36 is in simplest form, so we can stop there. Now you try it. In self-check number 2, power of a quotient, you have 2 times y squared divided by 3 times z to the 3rd, all raised to the 2nd power. Go ahead and work that one. We talked about the 0 exponent property just a few minutes ago, and you also covered this in pre-algebra, but any non-zero number raised to the 0 power equals 1. So some examples are 15 to the 0 power equals 1, 2 divided by 7, or 2/7 to the 0 power equals 1. So in example 3, we have 4n squared, q to the 5th, r squared, divided by 9n to the 3rd, q to the 2nd, times r, all raised to the 0 power. Because the 0 is outside of the parentheses, that expression is going to equal 1. In example B, we have x to the 5th, y to the 0, divided by x to the 3rd. So we're going to take x to the 5 minus 3, because we're dividing those, times y to the 0, which is 1. So the answer is just going to be x squared. Now let's try a couple together. In the first example, in guided practice 3, we have b to the 4th, c squared, d to the 0, divided by b squared times c. So we'll take b to the 4 minus 2 power, multiply that by c to the 2 minus 1 power, and we'll multiply that times d to the 0 power. So we get b to the 2nd, c to the 1st, d to the 0, which is 1, and we simplify that to b squared c. In the second example, don't really have to do any work. When you see that that 0 is outside of the parentheses, we know that that expression to the 0 power is 1. Go ahead and try a couple examples yourself in self-check number 3. Now let's look at negative exponents. Recall that 2 to the negative 4th equals 1 over 2 to the 4th, or 1 over 16. You learned this in pre-algebra, how to change a negative exponent to a positive exponent. You also learned that if you had 1 over x to the 2nd, you could change that to a negative exponent by making it x to the negative 2nd. Keep in mind that we need to simplify these expressions, and these are going to be the hardest ones that we have to do with division. Expression is considered simplified when it contains only positive exponents, each base appears only once, there are no powers of powers, and all fractions are in simplest form. So let's look at example 4. The easiest way to do these is generally to break them into different pieces and to try to make sense of it that way. So we're going to have v to the negative 3rd, and v to the negative 3rd over 1 is the same as v to the negative 3rd, just like 5 is the same as 5 over 1. And then we have w over w, and then we have x squared, and remember that if I put it over 1, it's just making it into fraction form, and then I have 1 over y to the negative 6th. So now we need to figure out what to do to simplify this. So v to the negative 3rd over 1 needs to be positive, so let's just go ahead and put 1 over v to the 3rd, and then we have w to the 1 minus 1 power, and x squared, and then we need to fix that 1 over y to the negative 6th, so we're going to have to put y to the 6th at the top in the numerator. So that's going to leave us with w to the 1 minus 1, which is 0, and we know that's 1, so we have x squared y to the 6th in the numerator, and v to the 3rd in the denominator. Let's look at one together. In guided practice 4, we have 32, a to the negative 8th, b to the 3rd, c to the negative 4th, and 4, a to the 3rd, b to the 5th, c to the negative 2nd. This one's a little bit more difficult than the last one, but we can still break it into pieces, and we have 32 over 4. Those are our coefficients, and we'll go ahead and pull those out. And then we have a to the negative 8th over a to the 3rd, and we have b to the 3rd over b to the 5th, and then we have c to the negative 4th over c to the negative 2nd. So the first thing we do to simplify these, we can go ahead and simplify 32 over 4 is 8. A to the negative 8 minus 3. B to the 3 minus 5. And C to the negative 4 minus negative 2. So that means we have 8. A to the negative 8 minus 3 is A to the negative 11th. B to the 3 minus 5 is B to the negative 2, or negative 2nd. And C to the negative 4 minus negative 2 is C to the negative 2nd. Now, we can't have those negatives because remember when we simplify an expression, we need only positive exponents. So we know that to change them, we can go ahead and just put them on the bottom. So we're going to have 1 over a to the 11th times 1 over b to the 2nd times 1 over c to the 2nd. Well, the 1's can go away, and that leaves us with 8 over a to the 11th, b to the 2nd, c to the 2nd. Go ahead and try one in self-check number 4. Take your time and consider what you're doing with those negatives. Just keep in mind that you can't have negative exponents, but you need to go ahead and follow my work in the one that I just did. I think that will help you to simplify the one in self-check 4.